So I'm conscious that it's now 2:30 in Vienna, 2:30 whatever the hour is wherever you are. So I think that's probably our cue to kick off. Ed, are you alive and well?
Yes, it seems.
Excellent. So welcome everyone. Welcome to the IETF113-DTN working group. We're very pleased to say that Vince Cerf has joined us to say a few words about the operation of the Ipn SIG and his opinions on state of play of DTN. So what I'm going to do is going to run through these chair slides pretty promptly because Vince's on a bit of a timeline, and then we can get straight on to him and then get on with the regular working group business. So as this is an IETF meeting, you should be aware of the note well. This meeting operates under the note well. If you have not attended any meetings before and have not read the note well, I strongly recommend you go away and do it in your own time. It covers IPR, behavior, the fact that you are waiving your rights to restrict. It gives us the rights to record for posterity any comment you may make at the microphone, and if you turn on your camera, etc. The BCPs which cover this in detail are detailed on this slide. Please reach out to the chairs, the AD, or anyone else within an old-time IETF. They can point you at the actual material. Because this is the first fully hybrid, I would say post-COVID, but I think that might be a little bit ambitious, meeting, there is an in-person participant tool as well as a remote participant tool. This is to keep Meet Echo operating well between those who are sat in the room and those of us like myself dialed in. We're operating a single mic queue, so if you have questions, please download the Meet Echo Lite on-site tool onto your phone. I think it's all done as a web browser. And that should allow you to join the queue correctly, and we can manage a single queue without, hopefully, too much disruption. It's been working well so far. So yeah, if you are on site, please keep your audio and video off, otherwise we get terrible feedback loops. Remote participants, it's just like it's been for the last 2 years. So just operate the Meet Echo website as you always have done. So here is a little bit of boilerplate, just in terms of the main agenda for IETF 113 is here. We'll cover the working group agenda in a minute. Meet Echo further information is also here. The irony being that I'm displaying this through Meet Echo, so if you can't see this, how do you see the URL? But hey. And if you need any technical assistance, there's a dedicated issues page. If you are stuck in the room and none of this is working, I suggest tapping the shoulder of the person next to you, maintaining COVID distancing, and ask them for help, and they can hopefully show you a smartphone with some kind of URL or point you in the direction of someone who can help. So, agenda. This is the admin's administrivia from the chairs. A quick 5 minutes just to cover where we are and what we're doing. And then we've got Vint kindly for 25 minutes, and then we're kind of into the meat of new charter items, updates on existing documents, and Ed and I both have a couple of questions to put to the working group, which we've done as a set of slides, which we'll squeeze in at the end. We've got quite a packed schedule, so we've only got 5 minutes for open mic, so you'll have to excuse the fact that I'm speaking quite fast and clicking buttons quite quickly. Administrivia. So there is an integrated note-taking tool. It was called CodeMD, but I believe Meet Echo have moved to a different tool. It's Markdown-based. It's interactive. Our secretary, Adam, is currently hopefully logged into it. I haven't checked. Please help him get the minutes correct, particularly around your name, which is always difficult to grab off the mic. And just double check if you're making comments that it's been captured correctly and your point was correctly documented. And if you're just feeling generous, please help us out keeping those minutes an accurate record for posterity. As usual, the mailing list is dtn@ietf.org. That's where the main business of the working group happens. So long drawn out conversations, we will point at the list, and please subscribe, monitor and contribute on the list would be great. If you want to contact the chairs, it's dtn-chairs@ietf.org. That's a great place for procedural questions. If you start asking us technicalities, we'll probably redirect you back to the list and continue the conversation there in public. One thing I did want to add after IETF 112 was we did discuss our rechartering. That rechartering has happened. I recommend people to look at the new charter page for the DTN working group. It is as was agreed at the previous IETF meeting. We've had the sign off from the IAB. It's fully approved and we can move ahead with the topics we wanted. And also, most important, we have 4 RFCs. So the last 6 years of hard work updating bundle protocol, TCP/CL, Bpsec, default security context around Bpsec are now a nice set of RFCs. So well done, the working group. That nicely bookends the previous epic amount of work we put in and allows us to start a new chapter, really, from this meeting onwards, looking at the next steps for the DTN working group. And I think that lines, unless Ed has anything to say. Ed, do you want to jump in?
No, that was a wonderful introduction. I just wanted to say congratulations for getting those first 4 RFCs done, and we're looking forward to the work that's in our charter. But now let's hear from Ben.
Yes, absolutely. I'll stop sharing and...
So Rick, just two things I want to say. First, please scan this one if you want to be, because we don't have a physical blue sheet this time, so please scan this one so that you are in the enlisted. So if you don't do that, you will be here, but you will not have that in the list. Please do that. And second one, I would like to repeat that congratulations to this working group. It has been nice working with this, and recharting went really well. And thanks to the chairs and thanks to the authors, to the 48, who has put a lot of effort to get the things right. So, Vint, after you.
Thanks, Ahid. Vin, we can see your speaker notes rather than your screen, just for reference. And I think you're on mute. Afraid I think you're still on mute.
Sorry about that. I'm puzzled because it worked just fine a moment ago, and I don't see why. What is it that I need to do to get it to show the full screen?
It seems to have grabbed the wrong window.
That's weird.
That's all right.
Okay. Well, let me stop. Let me stop and go back. Try again.
Oh, I have to click yes.
Okay. You want to share your screen? Yes. Chrome tab. Oh, I see what happened. Presenter view. Is that what I want?
I get confused in
Try this.
slides.
How's that?
Yes, that's it. You're there.
Wow. Considering I only have 2 slides, this is really painful. Well, first of all, let me thank you for allowing me to invade the meeting. I haven't been a participant in the DTN working group. And so I actually appreciate your tolerance. Second, congratulations on all the progress that you've made. And third, you have many folks around the world who are very, very excited about the work you're doing, the work you will do under the new charter, and the opportunity to demonstrate for many others the efficacy of the standardization that you've already accomplished. So I am representing in this talk the Interplanetary Networking Special Interest Group, which is in the process of becoming the Interplanetary Networking Chapter of the Internet Society. The Special Interest Group was formed in 1998, and it was parallel to the work that began at the Jet Propulsion Lab and has now expanded to a wide range of NASA laboratories, as well as other spacefaring agencies like ESA, JAXA, and others. So the effort over the past, now almost 24 years, has yielded a great deal of output, including all the work that you've done. So the IPN-SIG group is, as a small board, Yosuke Kaneko is the chair. He's also a senior member of JAXA. Scott Burley is the vice chair and has recently retired from the Jet Propulsion Lab, but is still extremely active, as you all know, in DTN matters. Mike Snell is the secretary treasurer and has served the IPN-SIG for many years. I'm just a member of the board. Oscar Garcia, who's present today in the call, is also the chair of our projects working group and extremely active in implementing both the DTN protocols and also applications that go on top of them, as is Alberto Montilla. And Keith Scott, all of you know, is extremely active at MITRE and the CCSDS program for standardization of the bundle protocols. We have over 800 members scattered, I won't say exactly uniformly, but not too ununiformly around the world, which is very satisfying. There's a lot of interest in the work that you're doing and in the prospects of interplanetary networking. The IPN-SIG has created a number of working groups in order to progress its efforts. The strategy working group produced a report in 2021, which is available on the website, and it looks to the next 100 years of evolution of the interplanetary backbone network. There's a projects working group led by Oscar Garcia, and it's actively implementing and testing the protocols, and I'll come to that in the next slide. There's an architecture and governance working group, which is asking the question, what does this look like as it begins to evolve, as we leave planet Earth and we begin to build an interplanetary backbone? What are the terms and conditions for operation? What if there are multiple parties who are implementing pieces of the interplanetary backbone? What are the rules by which the entire operation functions? And as we extend our human operation beyond planet Earth, exactly what does jurisdiction look like? What are the rules of the game for operating in space? So this is still more or less, I'm sorry, I'm being distracted by the fact that there are a bunch of guys hanging on the side of the building cleaning my window. There's nothing more slightly, weird feeling. I'm on the 16th floor of the building, and there are people who are watching this presentation. There is a library which is accumulating a great deal of information about interplanetary networking, and I urge you to have a look and also to contribute to that. Of course, all of the work of the DTN working group will show up in the library. There's an outreach working group which is intended to draw the attention of the general public to the work that you do, the work that the IPN-SIG is doing, and the CCSDS, in order to stimulate interest in space exploration and also the commercialization of space. Speaking of which, the last working group is a business working group, which is trying to understand what will be the way in which commercialization of space unfolds. And many of you who are watching the return to the moon will know that there are for-profit companies, SpaceX and many others, that are quite interested in what it might mean to operate in a commercial sense off Earth, ranging from mining on the moon to manufacturing in zero gravity to entertainment and travel. All of those things are possible, and we are, I think, at the cusp of that change as we see companies like SpaceX and others, Blue Origins, beginning to explore the possibility of, I would say, popular space travel. And so I think all of you might look at 2022 as a kind of a knee in the curve of possibilities for making use of space travel. Their strategy report is mentioned in the last line here of this slide. And I draw your attention to it because it's our attempt to summarize what might happen over the next 100 years or so. Here are our intentions, at least as I interpret them, as the Interplanetary Networking Special Interest Group. The first one is to implement and test a terrestrial and low Earth orbiting network based on the DTN protocols that you standardized. And the idea here is to make sure that people can see that this actually works, that it's a reliable, robust, and resilient system. We want to assure ourselves that the technology, the implementation of the technology is solid before we start sending things off planet to distant locations, because it's harder to fix things remotely than it is to fix them while we're still in a terrestrial operation. So this is partly to persuade ourselves and others that we have a scalable and operational system. In particular, we're very interested in assuring that the network management and security and configuration features of the design are actually implemented effectively and can be used easily by anyone building a piece of this interplanetary backbone. I'm sure all of you by this time appreciate that network management in a highly varied, delay, and potentially disrupted environment does not look like the network management that we've come to know in the terrestrial internet. Ping is not your friend in the interplanetary environment. We're interested in showing that these protocols are capable of supporting useful applications. And so we'll be testing messaging and real-time video and federated artificial intelligence and machine learning among a number of other applications. And we encourage all of you, as you think about possible ways of using the protocols that you've standardized, to inject those ideas into IPN SIG as well. One thing that's, I believe, pretty clear to all of us is that there will be multiple parties operating pieces of the interplanetary backbone in the same way that there are many parties operating pieces of the terrestrial internet. And so we're going to have to make sure that a multi-network construct actually works well, that independently operated but cooperating portions of the interplanetary backbone can actually interwork in the same fashion that the terrestrial internet has demonstrated. And so that's a very important issue to resolve. And finally, on this line anyway, we also need to make sure that various implementations of the bundle protocol will interwork successfully. So that's another opportunity for us to demonstrate the quality of the work that you've done. We are expecting to collaborate with a wide range of different parties. The project working group involves about 20 or 30 people, as Oscar Garcia can tell you, who are all working on various and sundry demonstrations of the technology. NASA, of course, has a DTN working group, and they are parallel to the work that you do. And they're busy implementing the protocols and testing them in a variety of environments, including the International Space Station, and looking forward to the return to the moon. LunaNet at NASA, Moonlight at ESA, among others, are programs that are being undertaken by the space agencies in the return to the moon. And of course, we expect the DTN protocols to be a part of all of that. At Utica College, there's a very active engagement in the implementation and test of the protocols, as well as Jorge Amodio, who is also present at this meeting, who has a testing laboratory. And I've left out a number of other players, and I apologize if I didn't include you in this list. I just want to make sure that all of you appreciate that there's significant and growing interest in the work that you've already accomplished, to say nothing of what you're going to do in this newly chartered period. I mentioned earlier that the commercialization of space and the departure from Earth creates all kinds of really interesting questions about the governance of operation in space, not just of the interplanetary backbone network, but all the other ancillary things that one could imagine, whether it's mining on the moon or space laboratories, habitations, on Mars, as we look further out into the future. The question is, how is that all going to work? And it's not obvious. Now, one thing that I can tell you is that in the Artemis return to the moon missions, a substantial amount of work on governance was undertaken in what's called the Artemis Accords, which are adjunct to the many space treaties that have already been agreed in the past. The Artemis Accords take a fairly broad look at what it will be like to function on the moon with multiple national and private sector entities all interacting with each other. Exactly what does that jurisdiction look like? How will disputes be resolved if there are any? What does it mean to own private property on the moon? How do we fence off historical sites like the landing, the July landing in 1969, among other sites? And of course, extending that to sites on Mars and other planets and moons of our solar system. So this governance framework discussion is bound to get off into a variety of weeds, and it does require substantial attention in order to make sure that we can operate in space in a friendly and cooperative way. And finally, this is the last slide and also the last bullet point. We're very interested in drawing public attention to the work that you're doing and the notion of an interplanetary backbone. And so we're looking at, if you remember, the search for extraterrestrial intelligence, SETI at home, allowed people to download an app that would take in radio signal, receive digitized radio signals to look for irregularities. What we'd like to do is build an SSI, Solar System Internet, at home to allow people to help us exercise a terrestrial implementation of the bundle protocol system in order to test its ability to scale up and to manage various and sundry failure modes to identify and recover from them. So there is a very significant agenda that the IPN SIG has adopted, and I hope that many of you who are already planning on standardization work will join us in implementation, test, and demonstration as well. So I'm going to stop there. Let's see if I can stop sharing my slides and return to the meeting and to thank you for the time. I didn't take 20 minutes or 25 minutes, and I think that that's good because you have so much work to do that giving you back a little bit of time seems like it's a good thing. And you've had enough of VintSurf anyway. So I'll stop there, and I have a few minutes before I have to go to do something else if there are questions or issues or observations that any of you want to make, or corrections if I've misstated anything.
So if we don't have someone sort of coming up to the mic task, specific questions, Vint, the one I would have is I look at the audience participation here, the number of folks we have, which is higher than we typically have. And so that says to me that we may have a few people here who are new to DTN as a set of technologies, new to the bundle protocol. As the mind behind the initial intention for standardizing store and forward, could you give just a couple of sentences to those who may not be familiar with bundle protocol on why this is the protocol for doing this kind of activity?
Well, I'm happy to do that. Many of you will perhaps remember that in 1997, a Pathfinder robot vehicle was landed on Mars successfully after 20 years of failure. The previous success was 1976 with the 2 Viking landers, and then nothing worked for a long time. So there was great celebration that we finally got back to Mars with a successful landing. The following spring at the Jet Propulsion Lab, I went out to meet the team that was responsible for the communications support for that Pathfinder project. And we asked ourselves then, what should we be doing now, that is to say in 1998, that might be needed 25 years later? And we came to the conclusion that we should think about an internet for the solar system in order to support manned and robotic space exploration. And of course, from today's perspective, also to support commercialization of space. So we said, well, can't we use TCP/IP? It works okay on Earth. Why wouldn't it work on Mars? And the answer is, well, it will work on Mars. However, we started doing the math for interplanetary distances and discovered very quickly that TCP with a 40-minute round trip time has a lot of trouble with flow control. So we decided it was time to rethink this very different parametric space, rethink the protocols needed in this very different parametric space. And we began to design the bundle protocols. And as all of you know, we've been through now 7 iterations of the bundle protocol design. Hopefully this one will be stable and we can now stick with implementing and reinforcing and standardizing it. But you can tell that the speed of light is simply too slow, and we can complain to Mr. Einstein about this, but nobody's found any way to fix that. So we've had to adapt our protocols to accommodate not only the variable delay, which is significant, but also disruption caused by orbital dynamics and planetary rotation, which we don't know how to stop either. So that's what led to the work that you are now presently engaged in. And it's actually been a lot of fun to be forced to rethink networking protocols in a different context.
Brilliant. Thank you, Ben. Zahed, you've got a question in the queue?
Hello. I hope you can hear me, right?
Yep.
Yeah. So first of all, thank Vin for being here with us and sharing this really exciting ideas and agendas. I mean, this looks really cool. So I think I have 2 questions to you, not really about this whole technology. One was like for this IETF working group, and we have recharted. I don't know, like if you have seen that one, we're more looking towards the addressing and how to reach things and maintenance and stuff like that. Do you have any particular suggestion or like an expectation from this working group that that we can take on with us as you are here?
I'm sorry, are you asking about a solution to add?
No, I'm thinking more like what do you think? What is your expectation, and what is this Ipn 6 expectation from the DTN working group in IETF?
Well, first of all, of course, we want you to continue to refine the protocols and to take into account that not only do we have to deal with these highly variable delays and disruption, but we also want this to work in real time. So for cases where we actually have low latency, I would like to be able to do streaming video like we're doing right this moment. I'd like to be able to build applications that will function reliably in the same way that they function in the present day internet. It's just that the architecture has to include the entire range of delay and disruption. And so when we have low latency, everything should work pretty much the way TCP/IP does. But when we don't have low latency, it has to work in the way that we intend with the DTN. So that's one thing. The second thing, I think, is that we'd like very much to see more energy put into applications to understand what it means to build a delay-tolerant application. And finally, I mean, among many other things, I'd like to exercise the naming and addressing structures in order to regularize them and come to agreement about how that should be managed. As you all know, we have in the internet the IANA, the Internet Assigned Numbers Authority, and on the CCSDS side we have SANA. And I'm hoping that that will be a parallel operation that we can rely on. And finally, commercialization. You should be thinking, what does this mean to use this stuff in this mixed environment where we have government investment and government operations and we have commercial operations? How does that actually work? And can we make it work in the same successful way that we have in the internet on Earth?
Yeah, thanks for this. I think from your expectation from this working group is like, I think we're already dealing a couple of things, the addressing thing, the maintenance things, the configuration part of it. I think this is great. And the real time thing, I think we need to have engage a bit broader IETF community to that one, like what, because we already have some established protocols for those kind of use cases, and bringing the bundle protocol and the same kind of thing might be a bit like we need to think a bit more holistic way of looking at it and see like how this fits into current architecture. But I think the point you made, like getting the architecture, this delay tolerant architecture into the so-called internet way of doing things, it'd be a nice combination to look on. So thanks for those words, and thanks for being here.
Well, thank you all very much. I do need to go off to another meeting, but I wish you well in the rest of this one. And certainly, again, thank you for all of the work that you're doing, because it's enabled us to be active in promoting the interplanetary backbone work that your efforts support. So I'll bid you adieu. Safe journeys.
Thank you very much, Vint. Thank you. And
Okay.
yes, run if you, I know you've got a hard stop, so thank you very much.
Thanks so much. Bye-bye for now.
Thanks. So just as I joined the queue briefly, because I have a presentation at the very end of the agenda for this meeting covering two of the points Vint raised about naming and addressing, and some early steps forwards which would allow some applicability within the terrestrial internet. So for those of you who can bear it, now that Vint has finished, please stay until the end, because we're going to cover some topics there which should open things. And in the rest of our agenda is equally as interesting. But big thank you for Vint in retrospect for speaking. So Ed, I'm going to hand over to you because I have spoken a lot.
Oh, no, that's totally fine. What I think that now, in the interest of time, we should go into our agenda items. My understanding is that we are going to present slides for our presenters and manage them so that individual presenters don't need to share their screen and otherwise go through their slides. Is that correct?
So the latest version of Meet Echo has the ability to share slides centrally and to effectively pass the next slide please functionality to the individual presenter. So they'll get a little strip appears at the bottom of the slide deck in their window, and they can click forwards and back. So Scott, I will pass the slide control for this slide deck, and you should see within your Meet Echo that you now have a little strip across the bottom of the presentation view, which allows you to step through the slides.
How elegant. Can you hear me?
Yes, we can. Hello, Scott.
Hi. All right. Well, let's start then, and I'll try to get through this in 25 minutes. I've got two presentations here, one on bundle encapsulation, one on quality of service, which are a couple of the items that are in the new charter. The bundle encapsulation presentation actually is very little changed from the one I gave in spring of 2021. This is to refresh everyone's mind on what this is about, and to introduce it to anybody who missed the earlier presentation on it. I think this is an important technological feature for deploying useful delay-tolerant networks in the future. So I think it's worth spending a little bit of time on. Let's see, is this going to work? Okay, good. I'm on slide 2. All right. The overview of the presentation, I'll give a short history of BIBE and talk about aggregate custody signaling in that context, the current BIBE design and possible applications, and then just a note on the future use of the thing. Short history. BIBE actually goes back to 2009. Some of our colleagues at MITRE Corporation put together this internet draft in August of that year, and the idea at that point was that bundle encapsulation would be a bundle protocol application. Now, the basic idea of BIBE is that you use bundle protocol to send bundles. That is the payload of a BIBE bundle is another bundle. It's tunneling and the same kinds of advantages of tunneling in the internet apply to bundle encapsulation in DTN, the specific motivations cited in that original draft were support for content-centric networking, forwarding cache bundles, targeted custodial retransmission of multicast bundles, which was an open problem at that time, and security, in particular, defense against traffic analysis, which nothing else that we were looking at the time would provide. We were busy with a lot of other things, so Bibe never really went anywhere for the ensuing 4 years. And I picked it up again in 2013, but with a slightly different organization. That is, instead of looking at Bibe as an application on top of bundle protocol, I think it's important to look at it as a convergence layer protocol underneath bundle protocol. So it still have bundles and bundles. It's just a question of where you stack them in the stack. And in particular, the idea at that time was we were trying to disentangle routing from security. There were problems with the original security protocol for bundle protocol, and in particular, it was like really locked into this notion of security sources and security destinations that made it possible for security to get in the way of effective routing. And this is a mechanism for getting around that if we wanted to preserve the specific security source and security destination features. At the same time, there was a lot of discussion of custody transfer in 2015, 2016. In particular, there were a couple of things that were discovered that what made it just not work. That is, custody transfer, as in bundle protocol version 6, had two significant problems. One was that the retransmission depended on accurate estimation of round trip time so that you could know when to retransmit. And in the general case, that was not possible because you didn't know who was going to be the recipient and therefore from whom you should expect a custody signal. So you had no way of knowing when to expect that signal and when to determine that it was late. Another serious problem was that the bundle fragmentation by non-custodians, which is perfectly okay, couldn't be prevented, and it would defeat custody transfer because anything that took custody of the fragments, those custody signals would not match up with any bundle that any current custodian had custody of. At the same time, though, there were scenarios, especially scenarios involving unidirectional links, where some sort of delay-tolerant asymmetric acknowledgement system was going to be needed, and bundle protocol was an obvious mechanism for delay-tolerant asymmetric acknowledgement. So why not use it for custody transfer? So the concept that emerged was that, and I will put this as a proposition, that bundle protocol transmission reliability is something that needs to be accomplished between neighboring bundle protocol nodes. It needs to be accomplished at the convergence layer because of the same problems that custodial retransmission ran into in Bpsec. In that sense, if custody transfer is going to happen at as a reliable transmission mechanism, that it needs to happen at the convergence layer. So we should use bundle protocol as a convergence layer protocol. And of course, hang on, Bibe is already doing that. So why not just add custodial retransmission as a feature of Bibe, so that Bibe would do two things independently or concurrently: cross-domain security with sources and destinations and giving us a defense against traffic analysis, and also reliable convergence layer transmission over asymmetric paths. Separately from all of this, back in 2012, there were researchers at University of Colorado Boulder that had designed a more bandwidth efficient definition of BPv6 custody transfer. It was documented in an internet draft that actually never got posted. Sebastian Kuzminski and Andrew Jenkins at UC Boulder were the developers, and it was very effective. It was developed as a prototype and implemented as an option in the Interplanetary Overlay Network implementation of DTN, and has been in use in operational transmission from the International Space Station for about 5 years now, and very well received. It's been highly successful in operations. The user community likes it a lot, and so if we take this aggregated custodial signaling concept and use that as the implementation of the custody transfer idea in bundle encapsulation, the result is this draft that was posted in May of 2018 and has been sort of sitting there waiting for somebody to do something with it since then. What you end up with is aggregate custody signaling as an optionally reliable convergence layer protocol underneath bundle protocol, and the encapsulated bundle can be encrypted and or signed, in providing additional security features that Bpsec itself does not. Here's the single slide sort of laying it all out. The payload of the encapsulating bundle comprises a transmission ID, which is used for linking custody signals back to the bundles that are being acknowledged, the expected time of acknowledgement for that bundle, and that's important for signaling to the recipient when to wrap up the aggregate custody signal and send it back so that it'll arrive in time to turn off the retransmission timers for the bundles that are being acknowledged, and then the encapsulated bundle. The acknowledgement itself is an aggregate structure that is conveyed in a new administrative record that is sent in a bundle that responds to the vibe bundles themselves. It includes a custody transfer disposition code, such as it's a reason code essentially, and then sequences of consecutive transmission IDs of received bundles. If the acknowledgement is not received by the expected time, then transmission of the encapsulated bundle is assumed to have failed, and the encapsulated bundle is queued for reforwarding. Something that came up in discussion of this with Goddard Space Flight Center quite recently is, what if one or both of the participating nodes don't have accurate clocks? We have the bundle lifetime mechanism provided for operations of at the bundle protocol, but what about bundle encapsulation? If there's going to be an expected time of acknowledgement, how is that going to be expressed? So that needs to be addressed in the next edition of this internet draft. Some mechanism that enables the sender to say, here's when I expect an acknowledgement, and for the receiver to understand that and use that as a trigger for sending the acknowledgement aggregated signals back. Okay, given all of that, I'll very briefly run over a couple of the applications for this technology, and then move on to the next presentation and maybe take questions for everything at the end. I think that bundle encapsulation actually is kind of, if you can set your mind to thinking about it, there are a number of weird kinds of scenarios that Vibe might be helpful for. Here's the one that the nominal mechanism that we use BIBE for, which is custodial reliability. Now that custody transfer has been removed from bundle protocol, we still want to have it. Here's a place for it to be, and here's a pictorial representation of how that would work. Similarly, cross-domain security. It may be that for large parts of the end-to-end path, the bundle doesn't need any particular security, and then it needs to cross a danger zone, and in across that danger zone, you encapsulate the original unencrypted bundle as the payload of a protected bundle, an armored bundle that crosses the no man's land. Defense against traffic analysis. If you even if the original bundle is safely encrypted, you may still want nobody to know where it's going to, where it ultimately comes from, and you can do that by encapsulating it in a BIBE bundle between two well-known points of the network, and the final destination is not revealed until the bundle reaches a safe part of the network. But that sort of transientness of security can be extended to transientness of quality of service. It may be that the bundle doesn't need any particular quality of service mechanism applied to it while it's in local subnets, but across the trunk line of the network, it needs some sort of special markings so that it's handled in a responsible way, and that sort of quality of service marking can be done with bundle encapsulation. Again, the transientness of BIBE is helpful for things like critical forwarding. That is one of the features of the extended class of service mechanism developed for Bpsec, is this critical bundle idea that ensures that the bundle has got the greatest possible chance of getting to its destination. Well, maybe it doesn't need all of that as additional sort of multicasting and multi-copying for all of its end-to-end path, but maybe for part of the journey it does, and a way to do that is to encapsulate the original bundle in a critical bundle, and that critical bundle you're sort of guaranteed is going to make it to the far end of the danger zone, and then the original bundle can be removed from that and just sent in the normal way. Transit multicast in the same way, maybe only part of the network needs to care about multicast in a way to ensure that the bundle reaches its destination by sending forward multiple copies. Source path routing is a sort of bizarre but actually potentially useful thing you can do with bundle encapsulation, just encapsulating multiple layers that will sort of guarantee the point-to-point transmission of the bundle along a specific sequence of forwarding elements. And combinations of these things, certified multicast. There are a number of weird things that you can do with bundle encapsulation, and still be well within the rules and the guardrails of a responsible bundle transmission. All right, so let's switch over to the other presentation, and I'll try to knit through it quickly.
Sorry, Scott, do you want to take questions on this now, or?
I can if there are some that are ready right away. I wanted to make sure to get through everything and not hold everybody up. So
Okay, I have one very quick question on that
Sure.
slide. On about slide 12 or something, you said something about one or both parties not having clocks. I wanted to just go into your. Do you mean they both don't have a synchronized wall clock, or do you mean they both can't count seconds or milliseconds?
They imagine one or both of. Well, actually, imagine the sender in particular does not have its clock is 0. It's a broken clock, and
Right,
so
okay.
right, and so it's identifying bundles strictly on the basis of a counter, and
But it can't measure time in any way,
right.
and it has
So the only
no
way
idea
that
of zero. Yeah.
the only way it can express the retransmission, the preferred rate transmission time is in an interval. Yeah.
Okay. Thanks. Yeah. It was Joshua, you're in the queue. If it's a quick one, go for it, or we'll hold to the end.
We'll see if this unmuting actually works correctly or not. So this is Joshua Deaton over here at Marshall Space Flight Center. And just a quick question, might just be my ignorance from being new to this particular group. For this BIBE, are we considering specifically tying BIBE and CT together? Or are we considering it more as BIBE being a standard and CT being more as kind of like an extension of BIBE?
So I'm going to step in as chair here. I don't think that is clear. In the charter, they are down as two related but possibly separate topics. And I want to ask that question as well, but can we let Scott get to the end of his presentation and pick it up there? Because I think that's quite an in-depth series of
Sounds good
questions.
to me. Thank you.
Yeah, no worries.
Okay. Let's switch to the other. And this one is much shorter. One second while I close this.
Is this in the same slide deck, Scott? Or is this a different deck?
No, it's a separate deck.
Okay, you should be able to change deck by the little button in your little toolbar. You should be able to say open new slide deck and find the next set of slides.
Okay. I thought you guys were doing that.
I can do that if you want.
If you can, yeah, that'd be great.
Okay, so I have to tell you to stop slide sharing. I then share, and it is that one. Share. And
okay, great.
Give you the control back.
Right.
There you go.
Excellent. And the little bar, can I get that bar?
You should have that bar. I have clicked the give control.
I'm not seeing it yet.
I'll keep clicking it, or I'll try doing it. Let me try resharing.
There it is. I got it.
Got it? Okay, cool.
Yep. Okay, good. Okay, the next is quality of service. And in addition to custody transfer being removed from bundle protocol in the BPv7 specification, quality of service had been in BPv6, and it also is removed from BPv7. So here's an attempt to cover the quality of service issue for BPv7 and elicit conversation on this topic. So what I will suggest to start off with here is that the fundamental job of the bundle protocol agent is to forward bundles to topologically adjacent BP nodes. That's basically what a BPA does. It needs to do a lot of other things in order to do that. It needs to compute routes and various other things. But the thing that it mainly does is forward bundles to other nodes that are topologically adjacent to it, using convergence layer protocols to do that. So when multiple bundles are queued up to be forwarded to a given topologically adjacent BP node, how does the BPA decide which one to forward next? And the BP specification is silent on this. by default, the queued up bundles are just forwarded in queue order, in first in, first out order. Quality of service would be a mechanism for, would be an alternative algorithm for making that decision on various bases. And among the considerations here are how urgent is this bundle? Which ones, you should send the urgent ones before others. And assurance that is a guarantee. So if some application has negotiated a guarantee that it gets 20% of the bandwidth from A to B, then if it's time for it to get some of that bandwidth, then that bundle should go, even if other bundles are higher priority, more urgent. So a quick survey of quality of service that I drew mostly from Wikipedia. The zeroth order solution for quality of service is over provision, right? If you've got so much bandwidth that every bundle that you present to be forwarded is forwarded immediately, then quality of service is moot. There's no queuing, so the next bundle that goes out is the one that is going out right now. You can over provision to some extent, but I will suggest that we'll never actually be so over provisioned that this is a total solution. So next, quality of service in the internet. I am very, very far from being an expert on quality of service in the internet. I hope I will not screw this up too badly. My understanding is that the two general flavors of internet QoS have been integrated services and differentiated services. InServ is negotiated service reservations for sender and receiver pairs. It was the earliest of the quality of service mechanisms developed for operation on the internet, and it worked fine, but it doesn't easily scale because the number of sender and receiver pairs that you need to support can increase exponentially. Also, it's sort of not a good choice for DTN because it's not delay tolerant. Negotiation in general is not a delay tolerant mechanism. So DiffServ looks like a closer fit. It's somewhat newer in the internet, although been around for many years. There's a differentiated services code point code, a value that is asserted in the packet header, a 6-bit number that selects per hop behavior, and the parameters of per hop behavior are things like priority, subject to admission control, assurance of transmission, that's the reservation sort of mechanism, again, provided that the traffic rate that was negotiated is not exceeded, and also likelihood of dropping a packet when the link is congested. Those are among the parameters that go into the per hop behavior options. There is no guarantee that a given router will exhibit the requested behavior for a given packet. There isn't anything that disqualifies a router that happens not to conform to the requested services, and the penalty for that non-conformance is really outside the protocol. It's a matter of business. Then the last part of this survey is, okay, what did we do in version 6? There was a class of service value defined in RFC 5050 based on the idea that DTN is somewhat like mail, and so the postal model of class of service was introduced. 3 classes of service: bulk, standard, which is like first class mail; expedited, which is like express mail; the processing of this was not defined. It's usually understood to be priority, but nothing in the protocol said it had to be. And it was frequently observed that this is all on the honor system. That is, it doesn't cost any more to mark a bundle as expedited than to mark it as bulk. So why would not all data be, all bundles be expedited? Why would you say, oh, please don't send my bundle slowly? I don't care. You probably wouldn't do that. So there was limited utility to the class of service as defined in RFC 5050, which is why it is removed. So there was sort of an additional internet draft that extended that class of service mechanism, prototyped in the ION implementation. There was that extended class of service included an ordinal tag, which is more layers of prioritization for expedited bundles.
Scott, I'm watching.
Yeah.
I'm watching the clock. You're 5 minutes over at the moment. Can you accelerate in some way?
Yeah, I am trying to, but I've got a little bit of a late start also.
No trouble.
There are service selection flags: best effort, reliable, critical, and a numeric label, a data label that is undefined. But likewise, that's just, anybody can say anything. So a problem with mechanism, quality of service mechanisms that discussed here is that there's an assumption there's no head of line blocking, that is, of course, quality of service gets a chance to operate fairly frequently. And that's the case for IP because packets are very small. Bundles are not. Bundles can be very large, so head of line blocking is very possible, and that would inhibit the operation of quality of service mechanism. We still need something. I'm suggesting here that what we might do is add a bundle processing flag for quality of service handling as requested, and only allow that flag to be turned on if the bundle is less than 64K, so that quality of service makes sense. And then along with that, say that all bundles with quality of service flag set to 1 get handled before any bundles with it set to 0, so that quality of service wins. And given that, you might define a quality of service extension block that has some sort of type of service request, something like the flags in ECOS, and or a numeric data label. And then add an IANA registry of data labels and the corresponding requested per hop behaviors in future RFCs. And again, let implementation of per hop behaviors be a node implement administration responsibility with no guarantees, same as basically diff-serve. That's the end of this presentation. So any questions we can talk about now in the remaining 12 seconds?
Thank you, Scott. Sorry to rush you there. It's we've got a tight schedule. Thank you for all of this. I think it's particularly the second part. I think you're heading definitely in the right direction as far as I'm concerned. That's me speaking personally, not with my chair hat on. Going back to your first presentation, the elephant in the room is, can we do reliability without custody transfer without requiring bundle and bundle encapsulation? And
the answer is certainly we could have. In my mind, it only makes sense to do it as a reliable convergence layer protocol. I don't think it makes sense anywhere else for the reasons that we removed it from BPv6. So it certainly could be a separate reliable convergence layer protocol, distinct from bundle and bundle encapsulation. My argument here is, why have two when you could use one to do both jobs? But I'm certainly open to talking about doing it a different way.
My reason for not combining the two was simply thinking in terms of overhead. If if the custody transfer mechanism uses an extension block or some administrative record, then you're not having to encapsulate an entire bundle and it's Bpsec information or what, how, these bundles can get quite fat. If you're not doing a full encapsulation, that might give you some more efficiency on the wire. Or am I misunderstanding that? Because I haven't got data on this.
If you're using if you're implementing a reliable convergence layer protocol, every convergence layer protocol encapsulates the entire bundle, right? So you really don't get away from encapsulating the bundle in something.
Okay, thank you. I need to go back and reread this, but thank you. Go ahead, Zahid.
So, Scott, I came up because of the third bullet on the current slide. So, no guarantees as diff serve. So, basically, I think if you look into if you would like to learn something from the diff serve, that it actually it didn't get deployed that much, or if it get deployed, it didn't used. So, it didn't deliver what it promised for. So, I mean, I think if you really would like to get the reliability, really get to get the differential service and everything, we might actually need to think a bit more before we kind of mimic what is in the diff serve. Just a question here. I mean, it all depends on what we want, but diff server is a not successful one. That's what I'm saying.
Right. If I came across as advocating that we implement diffserv, then I misspoke. I think diffserv is a very reasonable example of the kind of thing we want to do. I don't think it's the model for bundle protocol.
Yeah, that's then I'm on the same page there. Thank you. Because that's exactly what I think. I think this reliability thing, whatever prioritization we talk about, or whatever kind of different services we talk about, this service not really an ideal model for that one.
I am fully with you on that. No problem.
Thank you.
Sure.
Okay, I'm going to draw a line under the queue at this point. Thank you very much, Scott. This is all three of these subjects are really important and on charter, and we need to continue. Possibly even an interim on some of these topics might well be worth it, so we have a bit of time to drill into some of this. But we'll take that to the list to see if there's an appetite for that. So right, I'm going to retract your ability to show slides, and thank you very much, Brian. It's you. Let me share your single deck of everything and give you permission to take control, and on you go. Thank you very much.
All right, I can see it, and I combined all my slides together, so I'm just going to go through them. It's the rough order of priority here. So the first thing to talk about is maybe the simplest, which is the administrative record type registry, and what this represents is, oops, that in RFC 9171, there was an explicit table of record types, and BPv6 itself did not define a pre-existing record, but another RFC after BPv6 defined this registry. And the point of what this topic is doing is just adding BPv7 to the IANA registry as a column indicating the applicability in the same way it was done for bundle processing flags, block processing flags, and block types. And the other thing that recently I noticed was that, as Scott just mentioned, the CCSDS did standardize an aggregate custody signal, and that code point was never actually rolled back into the IANA registry. So I'll talk about that in a second. But all this is doing is it's just the bookkeeping of making sure that the registry is accurate and up to date. And then as a side effect of that, it becomes then usable for BPv7 allocations. So BIBE and an allocation that's needed for ACME to do node ID validation both would make use of this registry. And The registry, as it said before, was specification required. There's no plan on changing that. And because it's specification required, then on the next slide here, I'll show what the changes would look like. That code points 1, 2, and 4 were already pre-existing. 4 actually was the one that was missing, but because it's documented in a specification, it probably does belong there just to indicate that it is in use. And then the only other thing this document does is it makes a reservation for high value code points, which, because these are CBOR encoded eventually, mean that that last line is 32-bit values. So that's 4-byte encoding. All of the unassigned specification required are 16-bit values. And the majority of the specification is just text wrapping around the IANA table update. So on this topic then, this is still an individual draft. I'm requesting adoption of the document, and then at that point, details could be worked out about exactly what the text says and what the tables contain. But this is really just currently a placeholder for, there needs to be some kind of a record of administrative record type allocations. So that's it on this topic. Are there any questions immediately?
Yeah, just saying, noted your request for working group adoption. We'll do the relevant administrator on the list and just put it out there, see if anyone's got any objection, but it's a very sensible suggestion.
Okay, and it's quite short. That's the intent, is it's just touching this one table and that's it.
Yeah, yeah, indeed. You've got a slightly noisy mic. There's a bit of fuzz on that, if you can. Okay, thanks.
Try to take care of that. The next topic is a COSE context for Bpsec. This was discussed at earlier IETF, so I'm going to get right into detail. And some of this material is overlapping with previous discussion, but the idea is that Bpsec has a default security context that's intentionally limited in scope. It does the job that it needs to for a number of symmetric key algorithms. It doesn't include things like key identifiers that would be needed for certain rollover situations. And it's not, Bpsec is made to be extensible, but the default security context are just limited by design. So for internet-facing nodes and interoperation, especially for things that, like Scott was just talking about, security gateways, processing an unprotected external network, things like where you have to interoperate between agencies. That's where PKI is really the current standard of interoperation. And one way to get PKI immediately off the shelf is using COSE, the CBOR object signing and encryption. And it is almost purpose built for this kind of one directional security application. And on the next slide, I'll show some information about the idea here is that this is falling in the existing Bpsec paradigm. It's using existing parameters and result allocations. Everything, it's very nice that COSE actually does fit extremely well within the Bpsec framework that's already in place. And part of what this is going to do is it's adding more, even more extensibility to Bpsec. That in a even in a tightly constrained environment, there are abilities to use PKI with COSE that are already in practice and in use in other applications. And the last gain is really that COSE as an active working group is already in progress of standardizing on some hybrid public key encryption and post-quantum cryptography algorithms. So these things are already being worked. They're in active development. And a COSE security context would be able to take advantage of these things when they become available. So the idea here is that one context would be given for both BIB and BCB, and it's the type identifiers that distinguish the different uses. And this is how COSE already operates, that there's one COSE structure, and within that structure, there's a differentiation between signing MAC behaviors and encryption behaviors. And COSE also brings with it the ability to use a PKI environment, and also the ability to transport PKI secondary information. So COSE itself can embed things like X509 certificates, and in the future, potential other certification data. Then the one thing that COSE does not define is a real usage profile. COSE is fundamentally a container for security data, but it doesn't give you a tight definition of what belongs in a COSE message. And so part of this document is defining how do you put a COSE message in a Bpsec block, and the other part of it is what is the profile with which the COSE is supposed to be used. So this interoperability profile covers some symmetric key behavior, key wrap behavior, and the main new addition for Bpsec would be the PKI behavior and the asymmetric key behavior. So this table indicates these would be the minimum interoperability requirements. And some of these things are required, the symmetric key behavior, and some of these are recommended, the asymmetric behavior. Now, this is for an interoperability profile. This doesn't constrain or require any particular network to use any of these algorithms operationally. This is just saying for an interoperability, this is what should be supported. And none of these algorithms would be surprising to anybody who's using modern PKI, that these are the current, I would say, state of the art of current PKI, and PKI over X509 especially. And that is also one thing that the second point on this last slide is that the main benefit here to a network operator is that this structure, this COSE messaging behavior, is going to work, I would say, off the shelf in an existing environment where entities already have a PKI X509 environment, already have a certification authority, already have infrastructure for distributing certificates and keys. This is purely on the wire, how to get that information embedded into a Bpsec block. This document hasn't been touched in a while, so there's at least one known change that's needed just to bring this security context into alignment with the RFC 9173. It's not a change in the information content, it's only a change in encoding, and it's not even on the wire encoding, it's additional authenticated data encoding. There are some secondary questions that this is currently not a working group document, but if it were to become a working group document, then we would need to deal with more details like processing requirements beyond Bpsec related to the fact that when you're dealing with PKI environments, there's now a distinction between identifiers and identity that is authenticated. So just little details that need to be worked out for interoperability. And then the second item is really about are there additional minimum COSE header contents? So for example, SMIME, as it stands right now, does have a minimum that is more heavyweight than what's in this draft document, but maybe that's not really necessary. And this would be something that would be worth taking advantage of, learning from the SMIME upkeep working group, what is valuable and what's not valuable, especially in a large environment like what SMIME has to support. So that's my last slide on this topic. And it's not stated
Brian,
on the slide. Oh, go ahead. Yeah.
Right. Just to jump in on the queue, with my chair hat off, but just speaking from a Bpsec perspective, I'm a fan of this work. I think that the part of the idea behind a security context was BPv7 networks are going to be deployed in a variety of different ways, and the security context is the mapping of the block level fidelity that Bpsec requires to the underlying environments and networks where we will be running bundles. And so if we in this working group were to produce a context that tells us how to perform this block level fidelity in a PKIX environment, that makes a lot of sense to me. So with chair hat off, big fan of this work, and it would be nice to see it adopted.
Oh, and it's not on the slide, but I will bring up that there are discussions in NASA and I believe in CCSDS about the need for a kind of a interagency PKI type of thing, just in the general concept. And so I will propose that this is adopted by the working group and whatever needs to be done to further that along.
Brian, I've made a note of that as well. I'm watching the clock because we never seem to have enough time. We might have to book 2 sessions. This is just one of those things. So, all
right.
Do you want to move on?
Yep. The next topic is going to be quite short, and what it represents is the idea that there are currently applications that are doing processing on BPv6 and B7 at the same time, in the sense that the same entity is processing both types of bundles, and the convergence layers are currently shared in these entities between these different purposes, and there's not a well-defined way of receiving a chunk of data and saying this is a BPv6 bundle, this is a BPv7 bundle explicitly. And so in V6 and prior, the version has a specific offset. V7, because it's using a CBOR structure and because it's a nested structure, it's not a nested offset. And the root of bringing this up is that there are existing tools that assume that a BPv7 bundle is encoded exactly as some of the example bundles. And so that if the example has the version at offset 3 and size 1, that is how bundles operate. That these tools will break when they're given bundles that are still conformant to BPv7 but don't follow the same assumptions. And there's also separate from an agent that is processing this kind of data, there can be a need to identify a byte string as a bundle version and not actually have to process the full bundle, because a trivial way of saying how do you differentiate is throw this chunk of data at a V7 decoder and give me a result or an error, throw this at a V6 decoder. And the point of this document is to be a little more fine-grained than that. There's an existing document that defines a kind of a trivial mechanism to do this. But again, this is not looking at it from maybe an operational perspective of how a system should really do this. So there's 2 different aspects to this proposed mechanism. And one of them is, in the logical sense, how do you distinguish between these things? So the good news is that the 2 encodings actually don't have any collision between how they operate. So there's an unambiguous way of doing this detection. And in the logical sense, the general purpose algorithm of just saying, treat it as a stream of CBOR content and do a certain decoding sequence will do the job. So that's one way of doing it that will work in any case. That's the general purpose given a arbitrary chunk of data. That will work. That method will work. But part of what could be beneficial to have documented are some optimized, more optimized algorithms that do more of like pattern matching type behavior. And if you're in a network where you know that bundles are going to be produced in certain ways, that they're always going to use deterministic encoding, that they're always going to have certain properties to them, then we can do things in a more optimized way. So this these optimized behaviors are not strictly necessary, but it seems like there can be some value in at least having them documented in an informational way so that there's no need to reinvent the wheel in some of these cases. I'm not going to go through the optimized methods, but what they amount to is doing some non-CBOR decoding. So you wouldn't need to use a full-fledged CBOR decoder. You just need to do some bit operations that effectively do CBOR decoding. And then the optimized 2 method is byte string pattern matching. And if you're in a constrained environment and a fixed encoding environment, you can use pattern matching like that. But what this document would say is that you only can do this in a controlled environment. So feel free to do it, but just know that if you're given valid bundles, it might break your implementation. So this is not yet part of a real draft document. This is just saying, is there interest in this kind of thing? And the main benefit here is interoperability. The point is just to make sure that people don't create tools that are going into processing a received chunk of data that are going to fail in maybe predictable ways that we can try and avoid. And these steps are not parallel steps. These are sequential next steps of, if there's interest, creating a document.
Thanks, Brian. I think really interesting. This is me with my speaking personally. I think a short, concise, informational RFC has value just to maintain interoperability. Isn't that half the purpose of the IETF? So given there is V6 still flying, literally, it's worth making sure this decoder, the decoder logic is consistent, and that we can point implementers at best practice. I think there's some value in that. I'm watching the clock. I'm really sorry. Is anyone else in the queue with comment on any of these documents? Go ahead, Joshua.
Hey, so yeah, this is Joshua Deaton over here at Marshall Space Flight Center. In regards to the interoperability for V6 and V7 stuff, for our implementation of DTN-Me for use with the ISS, we did kind of follow the same general idea. Since we were starting with V6 to begin with, we did follow the path of verify whether V6, the actual encoding for saying we're using V6, is correct. And if it's not, then check if it's a V7 bundle. And if both fail, it's obviously malformed. But yeah, this is definitely something that at least we think there's some value in.
Okay, great.
Thanks, Joshua. In which case, Brian, because you're now over time, I'm going to hand swiftly on to Emery about. We are genuinely going to have 2 sessions next time. We never seem to have enough time. Let me share Emery's slides and hand over. Share. So, Emery, you should see a little sort of semi-transparent overlay to allow you to go left and right. How long have we given you? If I give you a 10-minute countdown instead of your 15, we can then overrun by 3 minutes, as we do with everyone else, if that's okay.
We'll make it work. Can you all hear me? Hello, hello?
I can hear you.
Okay, cool. Thank you. Yes, I see the slides. I've got the button ready to roll, and I will make it short. So first off, just to kind of talk about, this is a refresh of the asynchronous management architecture. This falls firmly under the new charter for an OAM architecture and solutions to meet network management. So just want to talk about the latest updates to the doc and ask really what are the next steps to move this forward, since this is the informational sort of motivation for why we need the network management architecture, and what are the approaches to that. So with that said, the first thing, we've renamed it to DTN management architecture. And this is just to sort of be more in alignment with what are we trying to solve here, right? So the new document is posted here. It maintains basically all of the same motivation, design principles, and concept of the previous document, just a little bit of clarity here and there. But the main focus and the reason for the renaming is this is a document that is designed to address challenged networks, i.e. the delay tolerant networks. So just to touch on some of the things that kind of have been clarified or updated in this document, the document specifies very clearly what are the services needed by a DTN management architecture and what are the desirable properties of a solution that meets these different services. So I called out a few here. Most of these were the same, but I called out a few here. So authorized administration and accounting and error control, asynchronous, dynamic, and highly logical architecture, model derived and hierarchically organized definition of information. I call these out because they are new sections, but they just are there to try and further emphasize, the scope and the need of this management solution. So to touch on a few of those, this is sort of AAA. I mean, one of the design criteria, you see this across almost every network management solution, is the need to authorize those controls, that reporting that are coming into the network management solution. Because this has to be built on top of DTN, it can't necessarily be built within the protocol as a very sort of synchronous handshake to set up these commands, but there is a need to do that. So a section, and there was verbiage all throughout the document kind of talking about this already, but I think it deserved a section that really described that need up front. So this new section states that. In asynchronous, dynamic, highly logical architecture. So this really speaks to the need to operate within DTN. Thinking kind of in the back of the mind, how does bundle protocol work? How does Bpsec work? So we're trying to say here that the concept of this topology is very dynamic. The roles assumed within the network can evolve over time. In fact, as a message moves from a sender to a destination, a new destination may assume that logical role, right? So we still need to deliver that to, in the case of a network management, a manager, but that manager might have changed. In addition, there might be multiple managers either coordinating or working with or receiving ports to a single agent. So we're trying to call that out up front and say that there's a need for this sort of logical architecture. The last change here was just saying up front that what we want is sort of a model-driven architecture. We talk a lot about autonomy in this model, which autonomy is often performed in other working groups or in other solutions as a very much sort of back and forth interaction between those managed elements and the managers. To achieve autonomy in a DTN management solution, we very much need a model-driven approach. And furthermore, it needs to support compression. And there's various different ways you can approach compression. So a hierarchically, organized, model-driven approach should give means to some of that. And I think a lot of these things that I'm talking about feed right into the approach of AMP and the data models that support network management as they've been being implemented, worked, and discussed in this working group for some time. I think as far as the high vision architecture, just calls those out up front. So a few other minor updates. This one here simply just walks through the roles and responsibilities of an agent and a manager, the agent being the thing that you're going to manage, whether it be the applications behind the space vehicle, the protocols that are managing the network on the space vehicle, as well as the manager, the node that is ultimately sending messages to those agents and receiving reports from those. So just a little bit of clarity, kind of walking behind exactly what is the role and the responsibility of each one of these roles. And then lastly, we updated some pictures in the back, I think to stress a little bit that this is indeed a solution for a challenged network management solution. So first picture kind of said, hey, look, Agent B here might lose connectivity for some time, even though it's generating reports to send back to the manager. It still is going to generate those reports and it will deliver them asynchronously at a future point in time. So it just calls that out in this picture here. The next picture, there is a statement that the agent should try and compress and combine messages where possible. So this effectively describes that, where agent B has been asked to produce 2 different reports. So from that time on, it combines those 2 reports and passes them as a single message. And some of this is actually handled maybe by the bundle protocol agent, not necessarily the network management solution. These get to work in concert to one another. And the last update to picture here is showing this multiplex management between fusion between potentially 2 managers that are both controlling the same or multiple agents. How are they communicating to one another? How are they fusing data and passing it? And this goes back to, like I said, the clarity of the roles of those logical agent and manager. So this picture tries to speak to specifically, okay, using that definition of the responsibilities of each, it tries to address that. So my questions to the working group. First and foremost, what is needed to finish this architecture? What is missing? What's wrong? We would like to move this forward. So that's the open question, right? And then are there any accompanying documents that need to go with this one? So I'll pause for a brief minute before I give my second section and ask. I see Ed's hand up.
So Ed, with my chair hat off, is to make an observation, which is at the beginning of this, we mentioned that this document had been renamed from the asynchronous management architecture to the delay tolerant network management architecture. And one of the observations there was the term asynchronous caused some confusion. Asynchronous as we use it in very challenged networks like a DTN architecture, mean that the transport layer is asynchronous. That you may have unidirectional links, you may have long periods of time without being able to communicate end to end. However, another use of asynchronous means not holding session state and perhaps just using restful interfaces over TCP. So one of the things that has to be done in this management architecture is to really differentiate the fact that asynchronous is asynchronous all the way down to the transport layer, requiring that level of autonomy. When we get to that point and how we use those autonomy models, the work is unique. So as long as we maintain that focus of asynchronicity all the way down to the transport layer, that needs to be there. So with that, that was just a comment, not a question.
Awesome. I saw Josh's hand go up.
Hey, so this could be something that I may have just missed because it's been a little while since I've done a true deep dive of some of these documents. But does the current state of the standard cover a situation for handling reports that have not been able to be sent for extended periods of time per se? So like obviously the nominal situation is that even if there's been a delay and you weren't able to send it right away, that it'll still try and send the next opportunity that it has. But does the standard provide a mechanism to say, if X happens or something else happens or something else happens, do something different with the report so that you don't all of a sudden send 1,000 reports down at once?
So others might have comments on this, but I think the standard doesn't have an answer for that, or the proposed document doesn't have an answer for that. However, I think that could be accomplished a little bit separately. So the concept of the logical data model that describes the rules associated with the generation or frequency of reporting, I think, personal preference here, that maybe we should have a capability to apply policy to those. So in the case like you described, maybe there's a system level policy which would be supported by an additional data model that says, okay, the lifetime of this, delete after a certain time, or when storage gets above this threshold, delete things that are older after this time. I think the AMA in particular, or the DTN-MA, I apologize, I've been speaking it too long, sets us up for, like I said, the motivation for that challenge network management, need for that logical data model, need for autonomous driven but deterministic behavior, which we can then add what you just described.
I'm going to jump in at this point. It's Rick with my chair hat on. First off, because I'm watching the clock. So I think to answer the question on the screen, I think having this is an and also to answer that previous question, this is an architectural document, and so I think it should be able to proceed without any accompanying documents. The accompanying documents can come after. That's commonly how one does architectural documents in the IETF. So I politely request working group participants to go away and reread this document. It has changed noticeably, and from my reading is a huge improvement. So thank you, Emery, and the rest of the team who've worked on this. Please reread, please review, and let's see whether we can really make some progress on this as an architectural document from which we can start to hang off the accompanying documents and address questions like Joshua's and get into the depths of data models and protocols and policies and all this kind of stuff. Does that sound reasonable? Yeah, good.
I like it.
So I'm conscious that Sarah got bumped out from IETF112, and I really want her to have an opportunity to present what she tried to present last time. So if there's nobody else, thank you very much, Emery, and we'll jump straight across to Sarah.
Yep, Roger. Did you want me to go through just real quick and let me do this real quick.
Go.
There is some additional information to the slides. There is a new document. It's right now a sort of personal document saying we need to have a method to name resources in the application models that are being defined. So my question, I'll kind of jump forward to this, and I think this needs work. My question here is this the sort of thing that the working group is interested in? And then, what are the next steps to kind of move that forward? So we can take that offline.
So again, as chair,
I
I think this is within scope of the working group charter. I think you should push this out as a personal draft. I think you should draw attention to it and garner interest on the mailing list. And what we're going to have 2 sessions at the next IETF because we have so much content. We'll have a proper dive into it, and if you get sufficient review, we go for working group adoption, etc., etc. But let's separate the track of that kind of thing from the progress on the architecture. Ed, are you agreeing or disagreeing?
I am agreeing. This should eventually come into the fold, but let's go on to Sarah.
Yeah,
Roger.
Perfect. Thanks very much, Emery. I will revoke your permission. This slide thing is almost very clever. There we go. So, Sarah, you should have control.
Yes, I see it.
Cool.
Okay, so if you all remember last time I presented about the Asynchronous network management system. This is a network management system we are creating to be able to operate the DTN protocols beside terrestrial networks. So next, I have a quick overview. Again, you probably saw these slides last time. So the goals of ANMS are to enable missions to be able to use the delayed disruption tolerant networks, help people use AMP and be able to adopt AMP, and also serve as the baseline for the AMP specification. So we will be tracking all the changes to the spec, and we'll be incorporating that into our network management system. So here quickly is what our layer 1 decomposition looks like. So at a very high level, that blue pill shape in the center is ANMS. We want to enable connections to other machines on the terrestrial network, as well as connections to agents in the space networks, and then allow mission operators to have some default visualizations into the system, as well as be able to do some command and control from or through ANMS. The ANMS services include, normal services that you'd see in a network management system, such as data management and service and storage, health and status monitoring, etc. But then also agent command and control through AMP. And we are also aiming for ANMS to be incredibly containerized and modular. So orchestration of the internal ANMS systems, and then also ability to plug in your own systems whenever it's useful. So for example, if you have your own visualization tool that you'd like to bring into ANMS, we want to have the standard interfaces and the modular system to allow you to bring that in instead of using our default visualizations. So that hopefully was a review of what I went over last time. And now the news is we do actually have our first spiral of ANMS complete and are ready to release it open source, I would say within a month or so. It's just going through the review process at this point. I do have it running in the background, but in the interest of time, I'll just flip through these pictures we have of it. So this is our welcome screen. Along the top, we have a few different tabs that we want to build out in the future. In our current version of ANMS, we have built out this monitor tab, the agents tab, and the messaging tab. And I'll go through those in a second. The network tab would show, the second one there would show like a network topology. Alerts would be alerts from agents, and system management on the end would be, in the future, things like health monitoring of ANMS itself. But going through the ones that we've built out, so the monitor tab, this is showing Grafana plugins for various variables within our system. So on the top left, you can see this is actually pulling variables from the BP agent full report and displaying them in this field. The one we've picked for this one specifically is num in cust, which is the number of bundles in custody for the agent. So here you can see we've been getting reports from an agent on our network and are able to display that variable for users of the system. Below that, actually in the middle, you can see all the reports that have come in kind of their raw form. And then on the top right is the message group per minute, which is really just a message rate. So how many reports have we gotten in the past minute? Right now, I think in this graphic, there's only one agent on the network, but we have run this with two, and you can see the difference between the two, and compare statistics between agents. So the key here is that it's really nice that we can now display all the different variables from all of the reports that you can get from BPv7 and AMP and all the different ADMs. So next slide is, zooming in on what I just mentioned. So right, but number of bundles in custody on the left side, and the message rate on the right hand side. But here we have the agents tab. So this one is showing the agents on our network, and this is where we can actually control agents. So we can send them commands, and we can receive reports from them as well. So at the bottom, you manage agents on your network. If you expand that, this is what it looks like. And this may be a little bit small, but the rather cool new feature that we added recently was that you can now automatically construct time-based rules here to send to agents. So if you select, start time, period, count, and then you can pick a report to ask the agent to push back to your management server on the period specified, then you can start populating data and displaying that in the Grafana pages that I showed previously. So right now this is supported for the reports that you see on the screen there, the LTP agent endpoint report, the BP agent endpoint report, BP agent full report, and AMP agent full report. But the really nice thing is this allows you to send these commands without having to construct them yourself. You don't have to construct CBOR, you don't have to construct REs, it just automatically does it for you. So just an example of some user-friendly options coming in the future. The less user-friendly way of doing this, you can see below that actually, you can send raw commands. So that other text box at the bottom there is, you can just send a CBOR command to the agent and it'll execute that. So if you just wanted a single report, you could construct that command and send it and receive the report back. So I believe this is my last slide. So this is the messaging tab. The messaging tab right now will help you construct those commands if you want to send one of your own. So here, if you input a string RE, then it'll parse that out. It'll show you what the CBOR is for that string. It'll parse it out into JSON. There's a tab there that will also construct a UML diagram of what it looks like, and it can do the same for CBOR as well. So if you put in a CBOR command, it'll parse it out and show you all the same data. So really quickly, that is what ANMS looks like right now in a nutshell. We're really excited to get this out into the community and to start getting feedback. And so hopefully it'll be there soon and we'll hear from all of you. Any questions?
Thank you very much, Sarah. That's really cool. It's really nice to see this stuff starting to run. It's really nice to see this as slightly more than a draft. We don't normally do show and tells at the IETF, but this was very, very worthwhile. It's just to demonstrate this is getting beyond the concept phase, which is great. So thank you. Anyone else got any questions on this at the moment? I know people were asking on the chat about, oh, can we play with it? What's it like? And Ed's chimed in to answer some of that. I'm assuming you can hear me because I keep getting a pop-up saying your audio isn't working.
No, we can hear you.
Cool. In which case, I am going to, because I'm watching the clock, I'm going to grab the slides and I'm going to jump straight on to my presentation. Thank you again, Sarah. I have a very quick, he says in advance, I'm going to turn my camera on so you can see me. So I've got a very shortish presentation asking 3 questions about endpoint IDs. So in classic form, I'm still trying to chase down more detail and drill into naming and addressing, but I'm tackling naming first. So a quick review, and I've stolen this slide from a similar presentation I did at IETF113. So this is an analysis of what RFC 9171 tells us about endpoint IDs. So the critical thing is they are a pair. So that is the schema and then some content which is defined by that schema. And 9171 defines 2 schemas, the Ipn schema and the DTN schema. An important other consideration, and I'm not going to go into it in too much depth at the moment because of time, is there is a multiplicity associated with an endpoint. So you can have the null endpoint, which is nowhere. You can have unicast endpoints and you can have multicast endpoints, but I'm not actually going to drill into that too far in this talk, but it's something to consider as we discuss the various types of schema. So I'm going to ask 3 questions. In fact, I may even have some answers to some of these questions. Question 1, if the DTN schema is for universal use, and the reason I say it's for universal use, and I'll jump back 1 slide because I missed this detail, is that the DTN schema, no, it's not on that slide. I'll come on to that. The DTN schema in RFC 9171 is registered in the IANA User Agent Schemas Registry. So that implies that it's for use in things like browsers, mail agents, on your mobile phone, generic user agent protocol handlers. That's implied by its registration. If I see you in the queue, Scott. If the DTN schema is for universal use, how do I write a protocol handler for a tool such as curl? Go on, Scott. I'll bite. Jump in.
I mean to interrupt you. Please go ahead. I was only. I'll respond to the slide before that said that there's no queuing of multiplicity in these things, and actually there is. The IPN schema is specifically always singleton endpoints.
Yes. Yeah, I think I draw that out, but it's kind of hit. That was a kind of a passing point, and I don't actually want to drill into multiplicity too much. It was mostly that slide was stolen from a previous presentation and had some points about multiplicity, but that's most relevant at the end. But point taken. So my second question is: given the IPN schema is restricted, and as Scott pointed out, they're unicast only, what should the working group recommend for its usage? Because it certainly has value. It's very condensed, it's very concise, etc. So I'm going to try and address that. I'm going to talk around that question. And the third question, which both Ed and I and various other people get asked, is: are these 2 schemas the only 2 schemas out there? And groups like CCSDS, SANA, IPN SIG are asking questions such as, well, how do we use these DTN IDs? Who owns the global registry for these things? Can we set up our own global registry? What should we do about problem X, problem Y, or perceived problem Z? And so I also address that because endpoint IDs are this combination of schema and content, and we have only currently defined 2 schemas. I shall answer that as part of question 3. So, question number 1, external use of the DTN schema. So as I said before, the schema is registered in the URI schemes registry, which implies they are available for universal user agents. So my question really is, how do I run this curl command? Using curl as an example, it's a great tool, but I want to upload that file to that DTN EID. So really, by doing a bit of analysis into that, looking at the rules in RFC 9171, a DTN schema specifies a name, a slash, and then a demux part, which is some other component. So I suggest that, sorry, that's the next slide. So you resolve into the name and the demux according to the rules in 9171, and you then transmit that uploaded file content using something that some information you have derived from that name resolution. 9171 quite correctly doesn't say anything more about that because it's the wrong document to do so. So I propose the following, and this is contentious, and I'm very happy for people to step to the mic and shout, but I might ask you to hold for a second. When a DTN URL is accessed externally, for example, using something like the curl tool, if someone was to write an extension to curl, then the URI is parsed according to the rules in 9171 into its name and its demux. And this is the contentious bit. The name component is then resolved using using DNS, not necessarily global, could be local. So it's resolved using DNS into an IP address. V4 or V6 doesn't make much difference to me. And then a TCP-CL v4 session is established to that resolved address in order to transmit the bundle. Example, that curl command performs the following operations. It's saying, send that bundle, protocol version 7 bundle, with the content of file 1 as payload to that destination, which is schema type 1, dtn.ori.co/some service. The some service is the demux part, using a TCP-CL v4 session. Got to make that acronym shorter. To the agent at that resolved address. Please don't ping that address. I'm not entirely sure where it is. Obviously, you'll need some other options to set some of the primary block headers, but fundamentally, that is enough to start using bundle protocol on the public internet infrastructure in order to send messages. A couple of clarifications. This proposal does not prevent either of the following. If your bundle processing agent is not something internet focused such as curl, but is some system built into a traditional DTN environment, so a deep space probe or something in a ground station or something traditional like that, doesn't make any difference. You can resolve that however you wish. You can use intermediate proxies and gateways between the user agent and that TCP-CL and that endpoint ID that one might use TCP-CL to get to. So there's nothing to stop you doing that at the ingress stage. And there's equally nothing to say that demux part of the endpoint ID after the DNS resolved part of the name, that could actually be an IPN address, or it could be some other deeper into the DTN network beyond the DNS resolved part. So that DNS resolved part is simply saying, here is something that is resolvable to an IP address that can be contacted using TCP-CL v4 that will take that bundle and get it to wherever it finally needs to get to. Okay, just going to quickly pause at that point to see if anyone has any major arguments. Go for
no
it,
major
Joshua.
arguments, but Rick, just because we have 2 minutes left,
Oh, shut
what
up.
I would say is, well, what I would suggest is that this is, of course, something we need to address. Can we start some posts on the mailing list and perhaps entertain an interim meeting to jump into some of these topics in more detail?
Yes, absolutely. I'm quite happy to take that to the list. What I'll do is I'll skip very quickly over the second slide and leave it on the third. Joshua, thanks.
Now let's finish up because we're pretty close.
Yeah, okay. IPN scheme, I am proposing that it is used internally for autonomous regions that Scott introduced. So it's effectively like a land scoped address. And this is an important slide for the IPN SIG guys. I have pointed them at this before. If you want to define your own EID, this is how you do it. Document it, request a new bundle protocol URI type scheme number. You're there, you're compliant. So that's it, I'll stop. Ed, you have about 20 seconds. I'm really sorry.
That's fine. Why don't you project the slide? I'll ask a question and then we'll take it to the mailing list, which I think is appropriate. And the question, really the fundamental question that I have is, in going back and looking at RFC 4838, which was published in April of 2007, based on and seeding some of the work in DTN-RG, we laid out what the DTN architecture is. Well, I didn't, but the DTN architecture was laid out in this way. My question to the working group is, do we feel that our implementation experience with BPv6 changes to BPv7 and some of the work that's happening now with network management, with security, with quality of service, with custody transfer, and so on, is it time to refresh this document? And that is a question out to the working group for anyone that wants to simply make a statement here about it or take opinions as to whether we need to refresh 4838 to the mailing list. That's really all I have on this slide. And with that, we are at the 2-hour mark. I'd just like to say this is wonderful to have the first DTN working group meeting after having our first 4 RFCs published. There's a tremendous amount of work. As you can see, we really did run out of time quite quickly. And we should start planning an interim meeting now, and then also perhaps have additional time at the next IETF 114, which perhaps will be all in person.
I also add thank you very much, all the contributors. Thank you very much for attendees. I'm going to keep talking and communicating on chat until Meet Echo shut us down because we're so compressed. Ed and I were talking offline. I think we're going to ask for 2 sessions next time because we always seem to run out of time. Although we are on paper quite a small group, there's a huge set of attendees on here, a lot of remote participants, and I think we have more work we can do at the next IETF as well as in between. So thank you very much for your attendance and your good questions. So yeah. I'm still typing rapidly in the chat, but I'm going to close my mic. Thank you very much. I think the meeting is over.
Indeed. It's good to see everyone.
I will be grabbing the chat window at the very last second and throw
Okay, no worries.
Cody, MD, Hedgedoc as well.
Good plan, and thank you very much, Adam. I had a chance to glance at the minutes as they were going past. Great stuff as usual. Those will be published as meeting minutes as ever, and as usual, the IETF will turn this into a YouTube video, much to my embarrassment, at some later date, so you can listen to the recording as well, probably focusing on the great presentation by Vint. So, yeah. Brilliant. Thank you all very much, particularly those in the room. Oh, and thank you very much to Ronald. Thanks, Ronald, for sitting at the front in case of emergencies. Really appreciated.
No worries. Thanks, Ron. Good.